This is drive period. From here to here it gives drive. After that this is off period. From here to here it is off period. At that time this is damping of the magnetic field. This damping of the signal due to this diode, this capacitor, and 1 and 2 resistors. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Haseeb Electronics. Friends, today I am going to share design details of power supply. This power supply, it is using SD6832 IC. It is giving 19 volt, 13 volt, that is to be considered as 12 volt, and 3.3 volt. This power supply is used in satellite receivers. I draw this circuit diagram of this power supply. I will share the details, how it is working, its working principle, its inputs and outputs. I connect oscilloscope to show you the frequency, switching frequency, its line and input. There is one fuse, line and input. There is one fuse here, and then there is NTC. Here is NTC 10D9, that is here. Then we have 4 diodes in bridge rectifier, 2 diodes connected to positive and 2 diodes connected to negative. Cathodes 1 and 2 cathode are connected to positive terminal of the capacitor. So the center 2 diodes are connected to positive, and the outer 2 diodes, anodes are connected to ground line. So here is capacitor, that is 6.8 microfarad, 450 volts. Then we have 2 resistors. We have 2 resistors at positive terminal, this resistor and this resistor. 470K, 470K, 2 resistors in series. And coming to VCC capacitor. Here is VCC capacitor and one bypass capacitor C2 that is connected here. And this negative jumper is connected to capacitor second side. Here is capacitor 50 volt for 47 microfarad. So this line is connected to positive side through these 2 resistors, and this line is connected from this jumper. Here is this jumper. So negative side of the capacitor, main capacitor, is connected to directly this capacitor ground, and it's also connected to the auxiliary winding pin number 4. The positive voltage of main filter capacitor directly connected to transformer winding. Main DC voltage, here are 2 resistors, 470K, 470K. These 2 resistors are connected in series and connected with this capacitor 47 microfarad, 50 volt, and it is connected to pin number 3 of the IC. It is current mode SD6832. It is current mode SMPS controller. So current is defined at pin number 2. This IC, pin number 1 is ground, and there are 2 resistors, 3R0. 3 ohm resistor connected to parallel, that means 1.5 ohm resistor in parallel. 3 ohm, 3 ohm. 2 3 ohm resistor connected in parallel. Pin number 2 of this IC is connected with 2 ohm resistors and is connected to ground line. This is main ground, filter ground. Then pin number 5 is not connected. Here pin number 5 is not connected. 6, 7, 8 are connected to transformer winding. So the transformer, this winding is connected directly to VCC side, connected to main filter capacitor. Positive side is connected to capacitor, and this side is connected to current mode SMPS driver. So this pin is connected to pin number 6, 7, 8. Pin number 1 is connected to ground. Pin number 1 is ground. So this pin is ground. Ground is connected here. So this IC will make pulses between pin number 6, 7, 8 and transformer winding between this capacitor. These soft start voltage are applied to this IC to start its function. When it will start switching, current is defined already at pin number 2, so it will start pulses. It will adjust its time period and then it will start switching. When it will start switching in the soft start mode, then we have output windings here, and here we have 200k, 2 resistors, 1 nanofarad capacitor, 3 component parallel and 1 diode FR107 in series for protection, because in off period this IC will make pulses like this. So in off period the collapsing magnetic field will be reduced by this reverse polarity diode and 2 resistors and this capacitor. Here are two resistors, 1 capacitor, exactly same here, and this diode. This diode connected to this point. This is IC terminals. 3 pins of IC, the 4th is diode. It is connected with 1 capacitor and 2 resistors, and it is connected to capacitor positive terminal. So when it will start switching, we will receive the voltage and output, and it will rectify through this 1N4007 diode, 1N4007, and third diode. The third diode is S360. This Schottky 360 diode, and here is a capacitor 1000 microfarad 16 volt. Then there is a choke, there is inductor, that is 4 microhenry, and then there is another capacitor, filter capacitor at the end, that is 220 microfarad 16 volt, this capacitor, and we will take 3.3 volt output, and this output will monitored at these 2 series resistors voltage divider network and this TL431. When it will take voltage, it will give a pulse to this optocoupler, and optocoupler will operate. This optocoupler will activate and it will give feedback. How the feedback will work? When this IC will start switching, suppose first of all it was in off state, in disabled state, it started switching. Here is inductor. Remember, at high frequency the inductive reactance will give a resistance to the current at high frequency. When it will resist, slowly the magnetic field will start to build up. When it will build up, we will take the output in the secondary. When it will start the building output in secondary, I am just talking very slowly, it is in kilohertz, it is 45 kilohertz. The frequency here 45 kilohertz. We are receiving voltage. We started to receive voltage because this magnetic field started to build up, and we started taking output. When this output is receiving at this end, this capacitor started charging. When it will charge, what will happen? We will receive a linear signal like this. We started here at this point. When it will start and it will reach, here we are receiving voltage, and this voltage divider network will start to give voltage at this reference pin. When it will take a standard voltage, because it will sense in millivolt, when we will receive the exact voltage level, that time it will produce the output at pin number 3. When this LED in the optocoupler will take its required output, it will start conduction. When it will start conduction, we are receiving voltage at output like this. And when we received the voltage here, suppose we need 3.3 volt. At 3.3 volt, what will happen? The diode LED will conduct. When this LED will conduct, this transistor will conduct at that time, and we will take a feedback pulse here. Okay, this optocoupler When optocoupler will conduct, at that time this ground line will connect it to pin number 4. So pin number 4 will take reference that the output level is maintained. At that time this drive pulse will stop. Then capacitor is charged. We are taking output at this output pin. Now when this voltage level will decrease, what will happen? It will go in off state again. When it will go in off state again, it will again give this feedback high, because the transistor will go in off state. When it will go in off state, it will make the pin number 4 high. So this IC will again start. When it will again start, we will take another time voltage like this. At that time the optocoupler will again switch. When it will again switch, we will take the feedback at pin number 4 again. So this loop will work again and again, and this IC will continue pumping, will continue switching to give drive to this primary, and we will take output in the secondary. So this power supply will continue working. Let's see the circuit, how it's practically working. For safety purpose, always use isolation transformer. Never touch to any electrical circuit which is live. It is for more safety. And always work on insulated workbench. Never use metallic table, and your working area must be clear. While working, never touch to any electrical component. So now I will demonstrate how we can check this circuit. First of all, set multimeter to AC. Check voltage at input terminal. It is 229 volt. Then we can check at main DC capacitor, that is here, filter capacitor. Set multimeter to DC and check voltage at DC capacitor. It should be 324 volt, 25, 26 volt. So what is the input voltage here? Multiply it directly to 1.414, and the voltage level should be at this capacitor. Your resultant voltage should at main capacitor 325. If you are using at 110 volt, 115 volt, so this voltage should 160 volt, 65 volt. So just multiply it if you are using bridge rectifier. So most of the power supplies are using bridge rectifiers. Check DC voltage at this capacitor, that is VCC capacitor. It is 12.33 volt. These voltage must be available here. This is positive terminal of the capacitor. Positive terminal, 1 resistor, 2 resistor, and after that if we see, it is reaching here at this point. It is 12.33 volt. These voltage must be present. If this resistor is burnout, or the path is disconnected and we cannot find the voltage here, our IC will not start. Now if we want to check switching, set multimeter to AC voltage, volt AC, and check primary input terminals. It is switching at 7.8 volt. So without load, so this IC is working perfectly because it is not consuming too much voltage in the winding. So when it will start switching, it will increase its duty cycle. That time the voltage will drop more in this primary. Now check DC voltage at input side of the optocoupler. That is 1 volt. second side, that is 0.26 volt, 0.25 volt. So this time this SMPS is working, and we can check the output at output terminals. 19 volt, 13 volt, 3.3 volt. Now if you don't find the output, what will happen? That is the biggest problem. If you have no good practical experience in working with power electronics, never do any practice power boards, power circuits. Now I will check. So this time we have this switching sample here on the oscilloscope. It is switching, it is adjusting its frequency at 39 kilohertz to 45 kilohertz. So this time it is working low, without load. You can see this is drive. From here to here, this is drive. After that, from this cycle to this cycle, this is drive period. From here to here, it gives drive. After that, this is off period. From here to here, it is off period. At that time, this is damping of the magnetic field, this damping of the signal due to this diode, this capacitor, and 1 and 2 resistors. This is function of these components. At 40 kilohertz, it's switching here. From here to here, this time when it will be calculated, it will become 40 kilohertz. At pin number 4, we are getting these pulses. When the optocoupler will on and it gives feedback, these pulses, this IC will receive these pulses, that there is voltage level completed. At that time, this optocoupler will generate these pulses, and it will give at pin number 4 the same purpose, the same here. When it will obtain its voltage level, it will give feedback to adjust its duty cycle. At that time, this pulse width will controlled by this voltage feedback, and that feedback at pin number 4 is here. Pin number 4 will take these pulses to adjust its duty cycle. At pin number 678, this portion is short. That time the IC is in burst mode. It will start switching again and again and again and again. If we see on the screen, it's again maintaining its frequency. And if it is short, it will try to maintain its level, and its switching frequency decreased at 8 kilohertz, 8.2 kilohertz, and it will switch again and again, again and again. We can see in the bottom right corner, it will give pulses, that is called burst mode, 8 kilohertz, and standard frequency, that is 40 kilohertz, 40 kilohertz. So any component short in the output portion, that will make problem. I am taking 3.3 volt, and if our optocoupler is bad, we will take fluctuation. If optocoupler is bad, the IC will go in, because this time the feedback is missing. If our optocoupler is not working properly, the feedback is missing. At that time, our multimeter is giving fluctuation, and we will find fluctuation. Anytime this IC is missing feedback, just a minute, I will remove this optocoupler. Now I removed the optocoupler from input side. Now the optocoupler is removed from input side. Now we will check the output. Now if we see here, this time I removed this optocoupler. Why? To ensure that there is no feedback. When there is no feedback, that time it is not finding any return pulse here. So in this period, when it will receive the voltage at output level, it should give these pulses, that the voltage level is maintained at the output end. But this time it is missing because optocoupler is removed. Now I will remove power and I will connect optocoupler again. Now I connect it, and it started again. It started again to switch at the required frequency, and we are taking the output. So I hope so this video is good for you. If it is good, like, subscribe and share if you want. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.